Okay, so here we go again. So, pleasant day to all of you. While watching this video, please do some taking notes because this is a very important part of our lesson. As I discussed in the previous videos, I gave a brief introduction about cache mapping. Specifically, these three techniques includes direct mapping, associative or fully associative mapping. We also have the set associative mapping. Please do take note that these techniques differs into criteria. That is, this criteria includes placing a new incoming block. Take note, placing an incoming block to a cache and replacing a block in the cache. Ibig sabihin po, itong technique na to, these different techniques, direct mapping, set associative, and fully associative mapping, differs primarily in these two criteria. So, kumbaga magkakaiba sila based from placing a fresh information to the cache and replacing an information in the cache. So, for this video presentation, I'll be discussing about the first technique, which is direct mapping. So, let's define first direct mapping. So, it places an incoming main memory block. Take note, incoming main memory block into a specific fixed position. So, places incoming block to specific position. So it places an incoming main memory block into a specific position. So the placement of the incoming memory block is based on a fixed relation between the incoming block number. So it is based from incoming block. Let's assume this as based from your module. This is I. We also have the block to place incoming block. Let's assume this as J. And then we also have number of cache block, let's say N. So the relationship, take note the relationship or the destination of the incoming block is based from these three variables. So the place for the incoming block, kung saan po natin ilalagay, that is, let's assume J, that is equivalent to I, take note, incoming block, this is the address of incoming block. So meaning this is the number of incoming block. So J is equal to I modulo or mode N. So meaning the location of the incoming block is determined by this formula. The location to place J is equal to I modulo N. For you to better understand, direct mapping, let's say we have an example. Before I discuss the example in the module, I'll give a specific example po natin. So, imagine a main memory of a size in blocks. Take note size in blocks, let's say that is 8 blocks. Then we also have cache, that is, let's say, 4 blocks with size of, let's say, 2 bytes. Okay? So, imagine this one. So, we have the main memory. Okay? So, we have so this is for okay, so this is our main memory. So block 1, 2, 3, 4, or 0, 0, 1, 2, 3, 4, 5, 6, 7. And then we also have a cache. Okay? Cache that is 4 blocks. Okay? 4 blocks. So 0, 1, 2, 3. Okay, so this is our main memory and this is our cache. Okay, so if we are to map this one, if we are to map the blocks in our main memory into our cache, okay, so we have 4 blocks in our cache. 4 blocks, that is 1, 2, 3, and 4. So 0, 1, 2, 3. So we have 4 blocks. According to the formula, so that is J, the location to place is equivalent to I mode, that is N. So where I is the main memory block number, and then N is actually the cache block size. So if we are to map this one, so 0, if we are to map 0, so that is J, that would be equal to J 0 mode 4. For 1, that is 1 mode 4. The same with 5, 6, and 7. So mode 4. So 6 mode 4. Then 7 mode 4. So what is actually the location of this one? What is actually the location of these main memory blocks into our cache if we are to map them using direct mapping? So 0 mode 4, that is actually 0. Do you know how does modulo works? So modulo mode is the remainder of division. So meaning, let's say for example, we have x all over y, then we have the quotient. Okay? So remainder is actually quotient minus the product of sorry. That is actually x, I should say. X minus the product of quotient multiplied by y. So R is equal to x minus q times x minus the quantity q times y. So this one, so that is actually 0 all over 4. We have 1 over 4, 5 over 4, 6 over 4, then 7 over 4. So if we are to map that one, okay, if we are to map that one, okay, so 0. So 0 divided by 4, that is actually 0. And the remainder, of course, is 0. So index 0 or main memory block number 0 is in the index or cache index 0. So for 1, of course, that is 1 divided by 4, that is 0. Then remainder 1. So this is here. Then for 2, it's here. For 3, of course, here. How about 4? It's 1. So 4 divided by 4, that is actually 1 remainder 0. So dito siya. So for 5, dito siya. So kasi 5 divided by 4, that is 1 remainder 1. So nasa index 1 po siya. Nakuha? Yung remainder po ang titignan po natin. The next 6. 6 divided by 4. 6 divided by 4, that is actually 1. And ang remainder niya, 2. So nasa index 2 siya. Then we also have 7 divided by 4. That is 1 remainder 3. So nasa index 3 po siya. That's it. That's how we map incoming blocks or incoming memory blocks into our cache. Okay? So let's take a more complicated example. Let's take a more complicated example. Okay? So the example in our module is this one. Consider the case of a main memory consisting of 4K blocks, a cache memory of consisting 128 blocks, and a block size of 16 words. So 16 words is actually equivalent to 32 bytes. So ito yung magiging mapping niya. Okay? So I just want to explain this one. So we have a main memory. Take note, main memory. So the size of that memory is size of main memory is main memory size is equal to 4K blocks, while cache memory size is 128 blocks. Of course, this is size of 16 word. So, just to illustrate nyo po, yung 16 word po natin is actually equivalent to 32 bytes. So, that is 0 to 31. Okay? Just to remind you, 16 words is equivalent to 32 bytes. So that is from index 0 to 31. Okay? So we have these memory blocks. So 0, 1, 2 up to 127. Then 128, 129, 138, 255, 256, and so on up to 4095. So actually that is 0 to 495. That is we have 4K memory location. Sir, paano po naging 1495? 4K, we are talking about 4K. Take note guys that we are talking about powers of 2. So 4K, that is actually equivalent to 2 raised to 2 multiplied by K is equivalent to 2 raised to 10. So that is actually 2 raised to 12. And 2 raised to 12 is equivalent to 4096. So if we are to index that one, that is 0 to 4095. So we have this one. Okay. So let's test. So 3968. What index or what cache block index is 3968? So to get the cache index of 3968, so 3968. So example. So 3968, that is actually 3968 mode 128. Kasi yung sinabi natin kanina, please do take note of the formula which is J, the memory block to place the incoming memory block, that is I mode N. So I is this one. So 3968 I should say, 3968 mode N, that is cache block number or cache block size. So that is 128. So by calculator, that is 3968 divided by 128. Okay? So that would be actually 3968 divided by 128. So the exact number is 31. So 31. Base from modulo po natin, mode is actually getting the remainder. So remainder is equal to 3968 minus the product of 31 and 128. So that is actually 0. So this proves that 3968 is in cache block 0. Okay, another one. Let's try 386. So 386. So that is actually 386 mode 128. Or that is 386 divided by 128. So 386 divided by 128. So that is actually 3. But what is the remainder? So to get the remainder, that is actually equal to 386 minus the product of 128 times 3. Okay? Sir, bakit 3 lang ang kinuha mo? May point pa tayo po. Disregard the non-integer part. You just get the whole number. So this is actually n. So 128 times 3. That is actually 384. So 386, of course, minus 384. That is equivalent to 2. Did we get the correct cache block number? So 386 nasa cache block 2 po siya. Okay? Please do take note that the advantage, ladies and gentlemen, the advantage of using direct mapping is its simplicity. Meaning, simplicity in determining a place for incoming block. So, madali lang kunin yung block number ng paglalagyan mo ng incoming block. But take note, the disadvantage of using direct mapping is competition of location. Okay? Later on, i-discuss ko ng mas maigi po yan for our incoming video presentation. But to give you an idea, imagine pag ang request ni CPU is ang request niya is 1, then 2, then 386, then 400, and so on. So, sabihin natin may may 4 na request lang si CPU. Okay? May 4 na request lang po si CPU. Now, sabi po na sa disadvantage ng competition of location, even if there are empty slots. So, if we are to find, take note, if we are to find the block number of this one, there's a possibility of competition. Bakit po? Kasi po, meron po, take note meron po yung mga different blocks or main memory blocks na napupunta sa iisang memory location. Parang ito. So, 0, 128, 256, 384, and so on is nasa block 0 lang siya. 1, 129, 257, 385 is nasa block 1 lang siya. E paano pag ang request lang ni CPU, ang request ni CPU is sunod-sunod na ito. 1, 129, 257, and 385. So, iisa lang ang pinaglalabanan nilang location where in fact the rest are empty. This proves that direct mapping is a many to one mapping. And that's all for direct mapping, and thank you for listening.